In this video, I'm going to discuss using the TI-83 or 84 calculator to do regression analysis with a data set. The data in this case is the population in the United States in millions as a function of the year. And the first thing we need to do is to enter this data into our calculator. To do this, we go to the Stat button and then choose Edit. The easiest option is to enter the independent variable into list 1 and the dependent into list 2. These are the default settings and they can make things easier later on. To enter the data, you simply type in the value, and if you then hit enter or arrow down, it'll take you to the next spot in that column. And so we go from 1790 and then we hit 1800 and so on. Enter and move me down again. If I want to go over to the list 2 values, I can just arrow over to there, type in 3.9, hit enter, 5.3, and so on. So we can do more with this. I'm going to ask you to pause the video for a second and enter all the data carefully. Thanks. The hope is that we've entered our data correctly. And one of the first things we do after we enter data usually is we'd like to take a look at it in a scatter plot. In order to do this, we go to second y equals, which is stat plot. We hit enter on plot 1 and then enter again to turn it on. And then the first of the types of plots that we have is a scatter plot, which is this one. So we want to leave that. We have put our x's, or independent variables, in this 1, our y's in this 2, and we'll leave this mark as it is. And so we're ready to take a look at our data. If we were to hit graph right now, we wouldn't see anything because our data isn't in the region from -10 to 10 in the x and y direction. So we could either create our own window, which wouldn't be too difficult, or we can use the calculator to help us create a window that fits this data well. And we do that by going to Zoom. And then number 9 is Zoom Stat. So we hit enter and the calculator can make a nice scatter plot. We notice immediately that as the years are going by, as we go left to right, the population is increasing, going up. We also notice that this is not forming a perfect line. The data is not perfectly linear, but we're still going to make an attempt to fit the best line to this data. And in order to do that, we go back to our Stat button. Now we move across to Calc. And number 4 is LinReg, which stands for Linear Regression. And I'm going to enter on that. And because our data is in list 1 and list 2, we don't have to indicate to the calculator what lists are in, but if they were in other lists, you would have to indicate the list by going to second 1, which is this 1, and then second 2, if it's in this 2, in that order, and then we can hit enter, and the calculator quickly computes the equation of the line with a slope of 1.36 and a y-intercept of -2,480.7, and it also gives you the equation in slope-intercept that shows you that form. This slope in this context is indicating that our line predicts the population to increase by 1.36 million per year. The y-intercept is not sensible in this context. It's the number of people that would have been around in the year 0 if the pattern had continued backwards indefinitely. But it is the y-intercept that makes the line fit our data. The next thing we could do is hit the y equals key, and we could take a look at our line. Since we've already run the regression, with the cursor blinking after the equal sign, if you hit the vars, which stands for variables key, and then number 5 in statistics, the third option over here to the right is equation, and then we hit enter on the regression equation, and it places that equation into our function list. Now if we hit graph, you can see how well the line fits the data. Now, there's a statistic in your calculator that you can ask it to show, and I think it's a good idea to show. Once you turn this on, it will stay on until you reset your calculator in some way. So I'm gonna do that right now. I suggest you do it as well by hitting second catalog, second 0, which is catalog. And the A up here indicates that it's already set on alpha, so we're about this D right here is going to bring us to the D's. And then down here, if we scroll down as diagnostic on, we want to hit enter once, and then again, and now diagnostics are on. So when we run the regressions in the future, by going to stat calc, number 4 is INREG, now we're going to see the same results, but we're going to have some additional information. We get this R value and the square of that value. We focus on the R value, which is called the correlation coefficient, telling you the strength of the relationship between your two variables, years and population in this example. If the correlation coefficient is positive, that means they travel in the same direction. So as X increases, so does Y. If it's negative, it would indicate that as X increases, Y decreases. Also, it gives you an indication of the fit by its relative size. A correlation coefficient of 1 would mean a perfect fit. Correlation coefficient of 0 would mean there's absolutely no pattern at all, it'd just be a cloud of points in your scatter plot. And a correlation coefficient of -1 would mean a perfect negative correlation. In this case, 0.96 is a pretty good correlation. There's clearly a relationship as years are progressing, population is increasing, so it's a strong correlation here. Okay, so what we're going to do next is just see if perhaps an exponential model might fit better. And so one way we'll be able to compare it by comparing the correlation coefficient, which both linear and exponential models, we can come up with a correlation coefficient. To do an exponential regression, we go back to stat calc, and we scroll down until we find xreg, hit enter again, and it takes a little longer to calculate, but it gives us an exponential equation with a being virtually 0, 3.3 times 10 to the -15. That would be the y-intercept. And the growth factor, b, 1.098. In this context, is indicating that the population is increasing at about 1.98% per year. And we do notice the correlation coefficient is higher, even closer to 1.98 versus approximately 0.96. And we can go back and put this new equation into y2 by going back to vars, number 5, statistics, over to EQ, the regression equation. And if we go back to graph, we can see our line there, and now we can see the exponential coming through. And it also is having a hard time going through all of these points, but it's doing a pretty decent job. The last thing I want to talk about is just how to use these models to make predictions quickly on our calculator. And so if I wanted to make an interpolation, for example, and try to figure out perhaps what the population was in 1955, I could go once more to vars, y vars this time. Number 1 is function y1, and that's my linear model. And then I can put parentheses and then just type in 1955, and it's going to substitute 1955 for the x in this top equation right here, and it's going to interpolate and tell us approximately what it believes the population would have been in 1955, and it has it at 178.8 million, which is between these two values, but pretty close to 1960. If we wanted to see what our exponential model predicts for that same year, we can hit second enter right now, which brings back the previous entry and allows us to edit it. I go over here and I just go back again, vars, y vars, and then instead of y1 we want y2, hit enter, and you can see that the exponential model predicts 161 million, which seems a little bit more reasonable. So in this interpolation, the exponential model seems to be maybe a little bit better. We could also extrapolate if we were interested in what the exponential model believes the population in the United States would be in the year 2015. Hit second, enter, leave Y2 because we're talking about the exponential model. Change 1955 to 2015, extrapolate out a few years, and this model predicts that the population would be all the way up to 523 million in 2015. And again, if you look at the model, you can see that the exponential model is going to probably overestimate the population because it's gotten very steep, even steeper than the data. So that's exponential and linear regression as done on the TI-83 calculator. I hope you enjoyed that. Thanks.